All right, so today here on campus, what we did is we did some enrichment problems, and here are the problems we did. I gave this handout, and then the students worked on it, and now we're going to go over it. So if you're watching this online, you can pause the recording, try these problems for yourself, and then hit resume when you're ready. Online students can also go to the course webpage and download this file as a PDF and try it out that way. So here are the first 4 problems. And then there's the last one on that section. And then nomenclature. There were a couple nomenclature problems, plus a couple challenge problems. And then the last part was relationships. So what's the relationship between each pair? All right. So when you're ready, hit resume, and we'll go over the answers. So now we're going to look at all of these here in class, see if we got them right. Okay, determine if each name is correct. If not, fix the name. Tell me what mistake the student made. So let's just draw it out, see if the name that we give matches the name that was given to us. I always have this problem. End of the week, especially. Used all my markers up and they're all dry. Cyclohexane, thiol, 5-methyl. So 1, 2, 3, 4, 5. Is that the correct name for this molecule? No, it's incorrect. What error did the student make? Right, wrong numbering. Right, you shouldn't number clockwise, you should have numbered counterclockwise. So you would go 1, 2, 3, right? Give lowest numbers. So what's the correct name for this? Right, instead of 5-methyl, it should just be, oh, that's a Sharpie, we definitely don't want to write with that. Instead of 5-methyl, it should just be 3-methyl, right? Everything else is fine. It should just be 3-methyl instead of 5-methyl. Okay, this is cyclopentane based. So 1, 2, 3, 4, 5. Let's see, 1, 3. 1, 2, 3, let's just say. 2-methyl. Is that name correct? Yes, name is correct. Because remember I told you there are 2 ways to name it. You can name a thiol the way your book shows, or you could split it up. If you're looking at this name in your book, this is the same thing as 2-methyl. How would your book do this?
Cyclo 1, 3 or methyl 1, 3 cyclo.
It would be 2-methyl 1, 3. Right, this is the same thing. Your textbook, instead of putting the 1, 3 as part of the parent, it just takes this and moves it in front. Right, so that's just the same thing as saying, you know, pent 2-ene, right? Or 2-pentene. So this is just moving it out front. So your textbook just moves it out front. So this is all one continuous word. They're the same thing. So yes, that is correct. We good on these 2? All right, let's move down to the next couple of problems. Heptane, I think you can figure this out now that I've been drawing it, right? Heptane 1, 2, 3, 4, 5, 6, 7. 7 heptane thiol. That's not right, right? Why is that incorrect? Right. Numbered, wrong direction. We should begin numbering here, right? 1, 2, 3, 4, 5, 6. So it shouldn't be 7, it should be 1 heptane. thiol. Okay, this is a pentane. 1, 2, 3, 4, 5, 6. Oops, pentane. 1, 2, 3, 4, 5. 1 chloro and 4. 1, 2, 3, 4. Is that the correct name?
No.
Nope. This is incorrect. What's wrong here?
The thiol has to take priority.
Right. SH gets lowest numbers. So we should number from the right. 1, 2, 3, 4, 5. So this should be what?
5 chloro, 2.
Right. 5 chloro, 2 pentane thiol. So the words put together correctly, right? But it's just the numbers are wrong. All right. Let's scroll up. No, spell check doesn't like that. All right, methoxycyclopentane. So, is that the correct name for that?
Yep.
Yes, that's correct. No problems with that name. All righty, that one was easy. Now let's go on to nomenclature. And I said you can use the method from your textbook, or you can use the correct IUPAC names, right? Because the textbook nomenclature for linear ones is kind of ambiguous. But for your textbook does use IUPAC nomenclature for rings. So what kind of group is this? This is a 1, 2, 3 carbon chain. So this is called a pro-oxy, right? So this would just be called, this is a 1, 2, 3, 4, 5, 6, 7. That's a 7-membered ring. So what would that be? Right. Proboxycycloheptane. Good. So there's only one way to name that one. Because even your textbook, which tries to just simplify it for you, right? Even your textbook uses IUPAC nomenclature for rings. All right, number 7. Where do we begin numbering?
I didn't know. I think you go from the top one.
Well, your parent chain needs to include the functional groups.
Okay.
Right?
You start on the
Right, because the functional groups take precedence over everybody else. And the only 2 functional groups we have here are thiols, right? Because these are just substituents. So our parent chain needs to include the functional groups. So our only options are to number this way or this way, right? Because both functional groups have to be included in the numbering. So we would number from the left, right? 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. So this is a what group? That's a propyl. And this is a methyl. So the numbering, so in terms of putting this thing together, we put M before P, right? So it'd be 4 methyl, then what? 3 propyl, then what?
2, 5 octane thiol.
Octane dithiol, right? Dithiol. So that di tells the reader that there are thiols on both carbons 2 and carbons 5. Carbon 5. Questions on this one? Okay. Now I wouldn't put one like number 8 on a test. I just wanted to see if you could Thank you, Tina. And you have to use the IUPAC rules here. You can't use the, I don't know, overly simplified nomenclature rules that your textbook gives. So how will we tackle this one? We find the longest parent chain, right? This would be the longer side. 1, 2, 3, 4, 5, 6. What kind of group would this be called? Ethoxy. Right, so this is called ethoxy. And then what kind of group is this? That's just a methyl. Right. So the name here would be 2-methyl. Then what? 1-ethoxy. And then this is a 6-carbon chain, hexane. Like I said, I wouldn't put one like this on a test. But challenge problem, test yourself. I would put something like this on a test, though. Just remove that methyl group. 1, 2, 3, 4, 5, 6, right? Because this would be fair game for a test. I just wanted to see what you do with that substituent, right? Your textbook gives an oversimplified nomenclature, right? It would say this is ethyl hexyl ether. But that's ambiguous, right? That's how your textbook would call it, though. And I wouldn't count you wrong because that's the way your textbook puts it together. But the correct name would be what? 1-ethoxy hexane, right? That's the IUPAC name. This is what your textbook does. Your textbook's just trying to simplify things for you. Right? It's saying, okay, it's 2 and 6 ethyl hexyl ether. But that's ambiguous, right? This is not ambiguous. So I would have accepted either one. So I just wanted to see if you could apply this to a substituent, see what you do. Like I said, I wouldn't put that on the test. Just want to, you know, stretch your brain a little bit. Did you figure out number 9?
I didn't. That was wrong.
No, it's not an amine. No, this one is just called benzene thiol. Right? Because if you had, just to compare it, what would the name of that be? This would be cyclohexane thiol, right? When you stick every other double bond, that's a benzene. So just use it as a comparison. If this is cyclohexane thiol, right, this must be benzene thiol. Again, that's not one of the ones you are required to memorize in terms of a functional group that's got a specific name like aniline or toluene or whatever. I just want to see if you can figure it out. Okay, and then the last problems dealt with relationships, deciding same, if they were the same molecule, if they were different molecules, unrelated, or if they were structural isomers. So let's look at these. First, we have to count our carbons, make sure we've got the same number of carbons. 1, 2, 3, 4, 5, 6, 7, 8. So this is C8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. SH. 1, 2, 3, 4, 5, 6, 7, 8.
So is it not SH2?
Oh, yes, thank you. There are 2 of them. You're right. The dithiol. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 2. Right, so that's the empirical formula for both of these. So they have the same formula, right? So we know that they're either going to be the same molecule or they're going to be structural isomers. How do we decide if they're the same molecule versus if they're structural isomers? Give it a name, right? So where do we number for the one on the left? If we go this way, 1, 2, 3, that gives 3 for thiol, 4 for methyl. If we number this way, 1, 2, 3, that gives 3 for thiol, 4 for methyl. So we could actually number either way, right? It wouldn't matter. 1, 2, 3, 4, 5, 6, 7. So this would be 4 methyl, 3, 5 heptane dithiol. And then for the one on the right, 1, 2, 3, 4 gives me 3, 4. 1, 2, 3, 4 gives me 3, 4. Right? So either way works here. So this is also what? 4 methyl.
3, 5, heptane dithiol.
Right. So what's the relationship here? Same molecule, right? That's their relationship. Same formula, same name, same molecule. One's just drawn a little bit differently. All right, let's go on to the next one. Oops, forgot to erase some of my numbers. Let's figure out the formula. 1, 2, 3, 4, 5, 6, 7. So C7. 1, 2, 3. There are no hydrogens on that one, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's do Cl, SH. We're not really worrying about order here. We just want to make sure we've got the same empirical formula. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So they have the same empirical formula, right? So now we're either torn between, are they the same molecule or are they structural isomers, right? Because they can't be different. So let's name them. Which way do we number on the molecule on the left? We number from the left, right? And we could start here or here, right? Either one. So 1, 2, 3, 4, 5, 6. So what does that give us for the name?
2 methyl.
Well,
Oh, no.
chloro comes first, right? So it'd be 4 chloro, then 2 methyl, then what?
2 hexane thiol.
Right. And then over here, do we number from the left or from the right?
From the left.
1, 2, 3, 4, 5, 6, 7. 4, 5, 6. Okay. So what's the name here? 4 chloro.
3 methyl.
3 methyl. What? 3 hexane thiol. So we conclude what relationship exists between these? They're just structural isomers, right? Same formula, but the thiol and the methyl group are in different positions on the chain. All right, number 12. I don't think we need to expend too much energy figuring this one out. I think you can just tell by looking at it. They both 6 carbon rings. They both have 1 methyl group and 1 thiol. But are the methyl group and the thiols in the same positions? So what would they be? These are structural isomers, right? Right, because this one, 1, 2, 3, would be 3-methyl cyclohexane thiol. And this one would be what? 2-methyl cyclohexane thiol. Right, so that one's pretty easy. You can just look at those and tell, okay, they've got all the same pieces. It's just my substituents are in different positions relative to each other. And then the last one, let's count our carbons. 1, 2, 3, 4, 5, 6. C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H14O. 1, 2, 3, 4, 5, 6. C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H14O. So they have the same formula. So now what do we need to do? We just need to figure out, are they the same molecule or are they structural isomers, right? So let's name these using both formats. Both the IUPAC format, which is less ambiguous, and the textbook version that your textbook uses. So your textbook would call this what? That's what the IUPAC name would be, right? IUPAC would say this is ethoxy. It'd actually be 1-ethoxybutane, right? Because this is carbon number 1, 2, 3, 4. 1-ethoxybutane. That's what IUPAC would call it. And your book would call it what? Right. Okay, now over here, what would be the IUPAC name for this?
I put dipropyl ether. So that's the
Dipropyl ether would work, yeah.
with no number.
No numbers. The other name that would work would be 1-proboxypropane. Right? This is 1, 2, 3. This is 1, 2, 3. So this is a proboxy group on carbon number 1. But dipropyl ether works just fine too. And actually, if you would have that showing up on a label too, and you would see that as a label. IUPAC would accept that. So based on this, what's the relationship? They're structural isomers, right? Okay. Questions on these problems? Anyone good? Okay, that's where we will stop.